been waiting way too long. Yeah, I've been down here trying to get it. Yeah, I've been waiting way too long.
This is the video for Geometry 11.6. We're going to be looking at area of regular polygons. Remember, a regular polygon is a polygon that is equilateral and equiangular, meaning all sides are congruent and all angles are congruent. So what I have here is a regular hexagon that has 6 sides. And so again, that means that all of these sides are congruent and the interior angles are congruent. So we need to identify some different parts of a regular polygon that we're going to need to use. So the center of this polygon is A, and I can draw different parts here. The first thing that I'm going to draw is the radius, and the radius is the segment from the center of the polygon to any vertex of the polygon. So all of these are the radius. When I draw 2 consecutive radii, I create what is called the central angle. So this angle 1 is a central angle. And the central angle is equal to 360 divided by the number of sides in the polygon. So that means that angle 1 is equal to 360 divided by 6, which is 60 degrees. The next thing that I want to show you is called the apothem. The apothem is the distance from the center to any side of the polygon. And remember, when we are talking about distance from a point to a segment, we want to make sure we draw that perpendicular. So this would be the apothem. That would create a right angle. So that is little a apothem. And the apothem really is, if you look at it, it's the height to the base of an isosceles triangle. So what that means is this A is the height. If I draw it over here, the A is the height of this triangle. And we know that's an isosceles triangle because the radii, the radius, are congruent. So again, we can look at this as really this hexagon is 6 isosceles triangles. So we have radius, we have the central angle, and we have the apothem, and we just looked at how this is really broken up, can be broken up into 6 isosceles triangles. So the formula for area of any regular polygon, not just a hexagon, any regular polygon, is 1/2 the apothem times the perimeter of the polygon. Notice I put a capital P, that is for perimeter. Now it's important to understand what the radius is because sometimes we need the radius to find the apothem. Another thing to notice about the apothem is that it will bisect the segment that it intersects. So what I mean by that is this apothem divides that side of the hexagon into 2 congruent segments. So let's look at an example. Here is a triangle, a regular triangle, which means it's an equilateral triangle. And I see here that the side of the triangle is 8 and the apothem is 4 square root of 3 over 3. I know that's the apothem because it's from the center to one of the sides of the triangle at a right angle. And so my formula again is 1/2 the apothem times the perimeter. So that's going to be 1/2 4 square root of 3 over 3 times the perimeter, which is 24, because there's 3 sides and all of them are 8. So now I'm going to simplify this. I'm going to simplify 1/2 times 24, which is 12, times 4 square root of 3 over 3. And then 12 times 4 is 48, so this would be 48 square root of 3 over 3, and I cannot simplify 48 over 3, so this would be my answer. Now in the next example, we don't have a lot of information. So again, this is a hexagon, and I know that it's a regular hexagon, so all the sides are congruent, and I know the radius is 8. So I'm just going to go ahead and draw the other radius here. So this would also be 8, and then I'm going to draw my apothem because I have to find that. And so what we need to use here is we need to consider what the central angle is. So because this is a hexagon, the central angle is 60 degrees. We already did that calculation earlier. So if this angle is 60 degrees and it is, remember, this is an isosceles triangle because you see the 8 and the 8. Then that means that these angles are congruent, which means both of those angles are also 60 degrees. So actually, this makes this an equilateral triangle. So what that means is this is 8, actually makes this pretty easy. So we know the side of the hexagon is 8, but we still have to find the apothem. So how are we going to do that? Well, this is also 60 degrees, okay? And this, the apothem bisects the central angle. The apothem bisects the central angle, so that is 30 degrees. So what we have here is we have a right triangle, 60, 30, 90. That's a 30, 60, 90 degree triangle. This is 8. And we know this is 4 because, again, the apothem bisects the segment. So now we can use special right triangles to find the apothem. So just as a reminder, we're going to look at the ratios of a 30, 60, 90 degree triangle. It is 1, the hypotenuse is 2, and the other leg is square root of 3. So we're going to write our ratios. You can see the 1 to 2 ratio with the 4 and the 8. So if this is corresponding to the 1, and then the a corresponds to square root of 3, that means that a is equal to 4 square root of 3. And if I were to set up a proportion, that would look like 4 over 1 equals a over square root of 3, cross multiply, 4 square root of 3 equals a. So that's how you find the apothem. So now we know the apothem and we can find the perimeter. So we're going to plug it into our formula. Area equals 1/2 times the apothem, which is 4 square root of 3, times the perimeter, which is 8 times 6, because each side is 8 and there's 6 sides, 48. Again, I'm going to choose to take half of the perimeter to simplify that way. So 24 times 4 square root of 3, 24 times 4 is 96 square root of 3, and that is your answer. So just like a lot of things that we've been doing, this is new, learning how to find the area of a regular polygon, but notice that we're still using some skills that we've learned in the past to apply to these problems.
I've been waiting way too long. Yeah.